So, I mean, all of you who watch the group to see what the topic for today is, you would have noticed that today I have not posted anything, and that's on purpose because I wanted to make sure that we continue with what we learned in the previous class with respect to unit circle, sign, cost and values, and then we'll see how do we extend that information to find out other values of bigger angles using the same unit circle. All right. So, and this will be more of a class where I would expect you guys to be more interactive, meaning I'll throw something on the table. I would want you guys to think about it and give me a response. It's okay if you're getting a wrong response, but it's not okay to assume anything. Okay, so let's get going. So all of you who saw how did we derive the value for different sine, cos and tan, let me put that in the table real quick because that will become our reference point. So let's say this is sine, this is cos and this is tan. So we looked at 0 degree, 30 degree, 45 degree, 60 degree and 90 degrees. And you just, hey Arjun. So all the kids who have joined just now, believe me, there's nothing that we have missed so far. Okay, so I'm just doing a recap of what we did in the last class. So I'm just filling the table that we prepared last week by finding out different values for sine, cos and tan. So I'm just filling it up right now, and we'll use this information for looking at different angles. So if you have to express this degree in radian, you will say 0 radian. So as you all know, 180 degree is equal to pi radian, right? So if it's 0, it's 0 radian. This is pi by 6. This is pi by 4. This is pi by 3. And this is pi by 2. No rocket science here. I'm just doing a simple calculation to convert the degree into part. So that if somebody says pi by 4, we should not be baffled to figure out what exactly that means. Okay, so I'm just putting that for reference. Now, and we'll see how we are going to use this information. So let me fill up the table real quick. All of you who know how did we derive it in the last class, wonderful. If you forgot, you have the video of the last class, you can just go through it, you'll be able to figure it out. So sine 0 is 0, 30 degrees is 1 by 2, 45 is 1 by root 2, it's root 3 by 2, and 90 is 1. Cos, in case of cos, it reverses. It becomes 1, root 3 by 2, 1 by root 2, 1 by 2, 0. And then it's sine by cos. So 0 by 1 is 0. This becomes 1 by root 3. This becomes 1. This becomes root 3. And this becomes infinity. So this is the value of sine, cos and tan that we derived in the previous class, and then we fill this table. We'll use this information to deal with, if somebody says, find out sine of, let's say 225 degree, or sine 225 degree. Who all in the class knows how to find it out and how much that would be? What you have is only this much. I'm just throwing it up on the table just to see what is your approach for this one. Yeah, Vishal.
I think you can subtract 290 degrees from it and like 180 and you'll get 45 degrees 3 left, and then 45 is equal to 1 by square root 2 maybe.
Okay, that's one approach. Any other thought? And again, I'm wanting you guys to kind of explore, think about it and give me options, okay? Because more the options that you guys have by thinking by yourself or listening to somebody else, you will have more options to play with when you are dealing with it by yourself. Any other thoughts? Any other approach that anybody can think of? Yeah, Michelle.
I just realized, and when it goes to negative, it would be negative 1 by square root.
Okay, so okay, negative 1 by square root. Okay, fine. I think you know how to do it. I'm wanting to bug everybody to get everybody's point of view, and then I will collate all that and give you guys one unified approach that might work. Anybody, and see, there's no need to be afraid of you being right or wrong. One last call. Anybody else? Yes, please.
I thought of the same thing too, adding two 90s values together and then adding a 45 degree
Okay.
together.
Alright. So let me simplify this for you guys now. Okay. So, and this kind of scenario we end up dealing with, something that comes to our rescue is unit circle. So without worrying about 225 degree, 275 degree, whatever it is, adding, doing any calculation, let's come back to unit circle and we'll see what exactly unit circle does for us. So this is my circle and I am calling it unit circle because the radius of the circle is 1 unit. Yeah. Now, if I am talking about 30 degrees, I am talking about this angle, which is pretty much, if you visualize this as a full-blown unit circle, we are talking about the angle in the first quadrant. Yeah. If I am talking about 90 degree, I am talking about this angle. If I am talking about 130 degree, I am talking about 90 plus 40, this angle. Yeah. If I am talking about 180, I am talking about here to here. If I am talking about anything more than that, I am going in the third and fourth quadrant. This part is okay, right? So it's all about traversing across this circle. Now, one good thing here is that after every 360 degrees, you come back to the same point from where you had started. Right? So, if somebody says, find out the value of 405, sine 405 degrees. You know that to come to 405 degrees, you would have made one complete circle and completed 360 degrees, and then you are left with other 45 degrees. So as long as you are able to find out the value of sine 45 degrees, you are good. So net what I am saying is, you have to just remember that whatever be the angle, after every 360 degrees, your counter kind of resets. After every 360 degrees or 2 pi, whatever be the case. Now let's come to this. Another thing that we learn about unit circle is that if you have a unit circle, any point on the periphery or the perimeter of the unit circle, the x coordinate is cos of theta and y coordinate is sine of theta. Correct? Now, depending on whatever be the theta, you will figure it out. Let's say, if I am saying x coordinate, meaning I am talking about the distance along the x axis. If I am talking about the y coordinate, I am talking about the distance along the y axis or the vertical axis. Is this clear to everybody so far? Let me know if I am talking gibberish at any point in time. Okay? Alright. So, stop me if I am going way too fast, if I am not making sense, if I am getting you guys confused. Don't hesitate to stop me. So now, we'll remember this. Now, let's look at this. If I, whatever be my angle, if I end up coming to this place, what will be my x and y coordinate of this one? Same thing, cos theta and sin theta. My x coordinate will be cos theta, y coordinate will be sin theta. What does it mean? My x coordinate, if this is the point, I am talking about this as my x coordinate. I am talking about here to here as my y coordinate. Correct? So what will be the theta? Let's say if I make, I travel this much, I come to this point, then what is my x coordinate? My x coordinate is this part, this length. Eventually, I will find out this angle, find out this height, this distance, find out this height, and this becomes my x coordinate and this becomes my y coordinate. My x coordinate, since this is along the negative side of the number line, this will be negative and this will be positive. So let's do one problem. So now Vishal, Pranit, you guys were helping me solve this problem. So now we'll take this understanding and go forward and see how do we solve this problem. So we are talking about sine 225 degrees. This is what I had asked you guys to figure out. Now first thing we'll do is let's draw a unit circle and figure out what exactly 225 degree means. Here to here is 90 degrees, here to here is 180 degrees. If I am talking about 225 degrees, meaning 225 minus 180, which is 45 degrees. So I am traversing another 45 degrees. So this is the point I am talking about. This angle is 45 degrees now. So whether you want to remember this formula, you don't want to remember this formula, you want to remember sin x, cos x value, doesn't matter. Just visualize this here. This is your unit circle. To make 225 degrees, you have to travel all the way from here till here. Now, see, this became a straight line, so I will probably ignore this part now. If I'm talking about sine 25 degrees, meaning I'm trying to find out the vertical component. This thing is cos theta is my x component and sin theta is my y component. So if I'm talking about sin theta, sin 225 degrees, meaning I'm trying to find out the vertical component or the y component of this point on this unit circle. Are you guys able to digest what I'm saying? I know this is among first few classes, so is it okay to digest so far?
Yes, sir.
Okay. So now we know that if I am talking about sine from 225 degrees, meaning I have traveled all the way from here till here, and when I come to this point, I can apply the same understanding of the unit circle to find out my x and y component. So my y component is sin theta. This is what we are trying to find out, meaning we are trying to find out the vertical component, the y component of this point where it's making 225 degrees. And here, just by looking at this unit circle, we can figure out, okay, this is in the third quadrant. So my x component and y component both have negative value. So whatever is the value of this one, if I take the negative value of that, will be good. So let's not worry about the negative part for now. We are looking at this as a right triangle, where this is 45 degrees, and this is what we are trying to determine, be it positive or negative, that will relate later on. So this is sine 225 degrees. Now here 180 you have already travelled, so you are talking about sine 45 degrees. This is 45 degrees. So if you look at this right triangle in isolation, you are looking at a right triangle with this angle being 45 degrees and this radius is 1 because this is part of unit circle. So this length will be nothing but your y component, which is sin theta, and in this triangle this is 45 degrees because 180 you have already covered. So this 45 degrees, sin 45 degrees, if you find out, that will be your absolute value, which is 1 by root 2. And to Vishal's point, why it is negative? You form this value as 1 by root 2, that is absolute value. But since this is in the third quadrant, so your x and y, both the components will be negative. So since we are talking about the y component, which we can clearly see, this is going to the negative direction. That's why it's minus 1 by root 2. Did it ring the bell for all of us, or I'm getting you guys confused? Yeah? Okay, so let's pick up one more angle, one more value. Let's say I randomly said find out cos of 240 and find out sine of 300 degrees. Cos of 240 and sine of 300. I will do cos of 240, I will let you guys do sine of 300. So my approach would be same thing, same. This is my unit circle. If I am talking about 240, meaning 180 I covered till here, and 60 more. So 60 more. This is 60. Now, so I will look at this right angle in isolation, okay? Now I'm trying to make it more simple. I will look at this right angle. 180 we have already covered, and 60 more. If I'm talking about this angle 60, if I find out the value of cos 60 for this one, which will give me the horizontal component, and that is exactly what will give me the value of this. For now, let's look at this as a right triangle. This is 60 degree, and cos of 60 degree is nothing but 1 by 2. So my absolute value is 1 by 2. Now we have to quickly check which location it is in, which quadrant it is falling in. So cos of 60, we are talking about essentially this length, and this length is falling in the third quadrant or fourth quadrant. I mean third quadrant or second quadrant, wherever. But regardless, this is the negative direction of x-axis. So whatever is my absolute value, I'll just put a negative to it, and that gives me the value of cos 240 degree. Did it make sense? Rehan, Prisha, everybody? Vishal? Vian? Yeah? Okay. Alright. So I want you guys to find out the value of sine 300 degree. And we have 2 minutes. Who can find out real quick? Value of sine 300 degrees. Can I assume that you guys are trying? Okay. And also, I want to find out the value of cos of 1140 degrees. So these two problems I want you guys to solve for me, because that will help us ensure if everybody has followed what we have learned so far. Yes, Vishal.
I think both of the answers are 1/2.
Both the answers are 1/2. Sine 300 and cos 1140 both are same, 1/2. Okay.
Yeah.
Let's see if anybody else got a different answer. And once I get 2 more answers, then I will probably ask one of you to explain how did you get to that point. Yes, Prisha.
Is sine 300 negative root 3 over 2?
Sine 300, you said negative root 3 over 2.
Yeah.
Okay, so this is another answer I got. That is good. I would have been disappointed if Prisha also would have said I also got the same value. Then that means, be it right or wrong, we are relying on one option. Okay, let's see. How about the other one? Prisha, are you doing the other one? Cos 1140?
Yeah, I'm working on it.
Okay. How about others? Dave, Chris, both the Chris, Vian, Rehan, working on it? Okay. No, I know it's post lunch session, right? There's a likelihood of falling asleep. So that's why I'm standing to make sure that I don't fall asleep. Let's see, yeah, Vishal.
For the sine 300, I think it's negative 1/2.
Sine 300? This one or this
Yeah.
one?
Sine 300.
Sine 300 is negative half.
I think it's negative 1/2.
Okay. Okay. What about you, Prisha?
Is cosine 1140 1/2?
I mean, I would not know. I will do it. I need one more answer. Three makes it complete. I have heard 2 answers.
I think it's 1/2.
1/2 for which one?
Cosine 1140.
Cos and okay. All right. So now I got 3 answers. So let me do my dirty job. So sine 300. I will again go in a very simple way. This is my unit circle. Sine 300 when we talk about how far we have traveled. This is 90. This is 90 makes it 180. And then 180 plus 90 makes it 270. And then I add 30 more. So this is 30 degrees. This is when I am making 300 degrees. So what I will do is I will drop a perpendicular here and perpendicular here to visualize this. So let's say this is O, this is A and this is B. If I look at this triangle, what exactly we are trying to find out? We are trying to find out this points. Sine 300 meaning we are trying to find out the y coordinate of this point, meaning this length. So let's not worry about 300 now. Now we are trying to find out this length. That's the goal. Now how do I find this length? This is same as this length. Meaning if I look at this right triangle, this is my 30 degree. This length I am trying to find out. And this angle is 1. So this is, if I look at this triangle alone, we are trying to find out this side and this one is 1 anyway because this is part of the unit circle. So this will be equal to cos, see this is the base, the angle applied to that makes sine, so this is cos. So this is cos of 30 degree will be this length in absolute value. So cos of 30 degree, if I am just looking at this triangle alone, so cos of 30 degree will be this length and cos of 30 degree we know that this is root 3 by 2. So we found the absolute length of this side. Now, since we know that this is falling on the negative side of the y-axis, that means whatever value we got, we just put a minus to it. So minus root 3 by 2. That will be the value of sine 300. Again, I am repeating, what did I do? I did nothing fancy here. To get to 300, I traversed across this unit circle. 90 plus 90, 180 plus 90, 270. So if I traverse 30 degree more, this is what I am getting to. So this point on the unit circle, the x coordinate and y coordinate remain the same, cos theta, sin theta. So we are trying to find out, so x and y coordinate of this will be cos 300 and sin 300. And that means my y coordinate is sin 300, this part. So if I find out this length, that will be more than enough for me. I don't have to worry about 300 to find out this length because we see that in the unit circle that to complete 300 I have to come to this point, and then when I join this point I see this angle is 30 degree. So if I find out this length and then look at the positive or negative side where it is falling, which quadrant is falling in, I will be able to determine that. So I will find out the absolute length and put a negative to that because we see that it's the negative side of y-axis. That should be enough. So let's find out this length. What did I do? I looked at this as a right angle triangle. I just took a picture of that here, and this is what I am trying to find out. So this, if this is my 30 degree, this turns out to be the base. So this length will be equal to this length divided by hypotenuse will be cos 30 degree. So this length by 1 will be cos 30 degree. Cos 30 degree we know it's already root 3 by 2. So root 3 by 2 turns out to be the absolute length from here to here. Since it is in the negative side, I'll just put a negative to it. That should be it. Is that Understandable? Yeah. Rehan, Vian, Dave, Aryan, everybody. And if there's anything that I'm creating confusion with, let me know now. I don't want you guys to accumulate confusions and then that becomes a wrong understanding. Yes, Aryan.
Can you explain it like one more time? My wife, I was kind of like.
Okay.
lagging.
So sine 300 is what we were trying to find out the value for. Sine 300. I'm just going back to my unit circle. Where exactly is sine 300? If I'm talking about a unit circle, any point on the unit circle, the x and y coordinates are cos theta, comma sine theta. This is what we know from a unit circle. Any point on the perimeter, the x coordinate is cos theta, y coordinate is sine theta, meaning the distance from here to here is cos theta, here to here is sine theta. Now, if the theta changes, meaning if this angle changes, if this guy moves, this formula will remain the same. So, if I am trying to find out sine 300, let's see how far I am traveling. This is 90, this is 90, 180, plus this 90, 270, plus 30 degree. This is how and where I am completing sine 300. So, this 30 degree is complete, making me complete 300. That's what I am trying to find out, right? Yeah, Chris.
Sure, in this question, after you have like 30 degrees, is there any way you can use the 30, 60, 90 triangle?
Yeah, you can. So that's what we are doing actually. So once I come to here to make sine 300, I'm just looking at this triangle in isolation, okay? I'm not even worried about 300. I determined that, okay, this is my right angle triangle and my y component is this length here to here and my x component is here to here. So I will just take that information for relating it, okay? Saying that if I find out this length, that will give me the value of sine 300 degree. That's what I am trying to determine. And I am not even worrying about 300. I am worrying about this triangle now. This right angle triangle says that this angle is 30 degree and this is 1 because it is part of unit circle. So what is this length is what I am trying to determine, because this length and this length will be the same. So what is this length? So let's say this is x. So x divided by 1 will be equal to cos 30 degree, correct? That is by the SOHCAHTOA, correct? The base by hypotenuse gives you cos theta. So and now we know cos 30 degree, we already know, is root 3 by 2. So I'll put root 3 by 2. So that gives me the value of x as root 3 by 2. This is my absolute value. This just gives me how long it takes. Whether it's positive or negative, that will again determine by looking at the unit circle again. So now we found this absolute length as root 3 by 2. Since this is in the negative direction, so I'll put a minus to it and that should be my answer. Does that make sense?
Yes, sir.
Yeah. Chris, is that clear better? Yeah?
Yes, sir.
Okay. Alright. So now same thing. Some of you solved that, this one I'm not sure whether that's correct or not, but let's do it. So cos is 140 degree. And though it looks like a bigger thing to deal with, it's not. Same thing, I'll go to unit circle. First let's locate the point. And as we know in the unit circle, after every 360 degree it gets reset. So let's see how many times it got reset. Here to here 90, 180, 270, 360. So one complete circle is completing 360. If I go for second iteration and complete from here to here, I am completing 360 plus 360, 720, still less than this. Can I go one more circle? 720 plus 360 is how much? $1080. So it's already got reset 3 times, okay, to get to 1080. Now how much we are remaining with? 1140 minus 1080, 60 degrees. So 3 times it already got reset and then another 60 degrees it travelled to come to this point. So now if I'm trying to find out cos of 1140, meaning the x component of this triangle, x part of this. Now I'll not worry about 1140 and all. I know that I have to find out this length, and then this length I can find by finding out the length, keeping this 60 degree in mind. So again, this is x component, right? This length is x component in this triangle. Let's say this is x. So x divided by 1 is nothing but cos of 60 degree. What is cos of 60 degree? We know that it's 1 by 2. 1 by 2. So my x value is 1 by 2. Now I'll just check whether it's going to be positive or negative. I see that behind the first quadrant. This angle is in the first quadrant, where my x and y, both the values have to be positive. Done. Yeah. So this is where there are two things. You keep this unit circle in mind to locate, to see how many times you are iterating through this circle to get to the angle that you are looking at, which quadrant you are falling under, find out the absolute length, and then do one more round of validation to see whether it's falling in positive side of the axis or the negative side of the axis, and that should be it. Yeah. Are we clear? Or is everybody clear? Yeah?
Yes, sir.
Alright. So, let's do a quick recap of what we have learned since the last class. Because today I wanted to teach you guys something and also make sure that whatever we are learning with the unit circle, how do we relate that with plotting of sine, cos and tan graphs. And then we will look at probably taking a break for one day. So tomorrow I'm planning to skip the class. Okay, I have my family members visiting here, so I'm planning to take a break for next class, which is tomorrow. We'll figure out how do we compensate for that one. Okay, so maybe we'll pick up one of the pre-calculus class, or we'll pick up any other class where we can catch up for the class that we are missing tomorrow. But then, so we have learned how do we plot sine and cos curve in the coordinate plane. We learned how do we find out different angles, right? We were using these angles for plotting this, the sine and cos curve. And then we were kind of getting stuck with sine 30 degree, okay, 1 by 2. How did we get that? So then we looked at how these formulas are derived also. So if some of you are not clear how these values are derived, we looked at some of these, and probably next 20 minutes we can spend on proving, kind of doing a recap of how those values are derived, or how what formula or what approach you can use for deriving those values, and then how do we use that for plotting the tan curve also. So do we really want to understand how do you get the value of sine 30 degree, sine 45 degree, sine 60 degree? I'm just asking, if anybody in the class thinks that you don't recall how it is done, how it is derived, let me know. Otherwise I'll assume that everybody knows and I'll move on to the next thing. I think Aryan knows, that's why he left. He has heard so many times from me. Maybe it's a question for Vian. Vian, do you know how to determine, if I'm saying sine 45 degrees 1 by root 2, how do you determine that?
Yes, sir, I understand.
You know that already, okay? Anybody in the class who is not clear? Okay, then I'll assume that everybody knows. And if you guys get stuck anywhere, let me know. I will come back to this. So one thing is guaranteed, okay? In this class, whatever we learn, you will forget. And that's pretty natural. So if you forget something, we can come back to the topic, do the scratch work one more time, make sure that we are clear. If at any point in time, if you guys get stuck anywhere, don't be shy. Oh, this is something that the teacher explained 3 times, I should not be asking one more time. No, that's not right. Now, today in the class, we'll learn about how do you draw the tan curve. We have learned about how to draw the sine curve and cos curve, okay, which is called sinusoidal curve or cos curve. Today we'll talk about how do you draw the 10 curve. Nothing fancy about it, but before I start, has anybody tried drawing a 10 curve before, or do you have a fair understanding of what exactly it is? Yes, Vishal.
I have never drawn it, but I've seen it before.
You've
It just
seen it.
goes top to bottom, like in a curved way.
Okay. So, I mean, while I cannot dare to disagree with what you said, Vishal, but me being a little mischievous person, I don't believe anything without doing it myself. So let's do it. So if I'm talking about draw something like y equal to 10 of x, where x is the angle. No big deal. When I'm talking about drawing something, of putting on a graph, the first thing we know is you have to create a table to find out the x and y values. When I'm looking at this is nothing but an equation for us, where there is a contract between x and y. When x is the angle, y is equal to 10 of that angle. So same thing applies. If you're looking at a linear equation, quadratic equation, or a function like this, doesn't matter. It's the same. There is a contract. There is an agreement. So let's look at. I'll put y here and x here. And here I will deal with some easy looking numbers. So let's say if I am talking about 0 degree, if I am talking about 30 degrees, if I am talking about 45 degrees, if I am talking about 60 degrees, if I am talking about 90 degrees. Or in radian you will say 0 radian, pi by 6 radian, pi by 4 radian, pi by 3 radian, pi by 2 radian. Okay. So that makes us go back to the table of 10, where we know that table of 10 is sine by cos, and you will see that if we deal with these things so many times, you end up memorizing it without putting any effort for it. So that's what I'm going to do. So sine 0 is 0, 1 by 2, 1 by root 2, root 3 by 2, 1. 1, root 3 by 2, 1 by root 2, 1 by 2, 0. Sine by cos, 0 by 1, 0, 1 by root 3, 1, root 3, infinity. So, now you look at this. Let's say on this side, we are putting x, which is my angle. So this is 0, this is pi by 3, pi by 4, sorry, pi by 6, pi by 4, pi by 3, pi by 2. And then on this side, we'll put the numbers. Let's say 0, this is 0, 1 by 2, 1 by root 2, 1. I'm just making it up. Now look at this. When when 10 0, when x is 0, 10 0 is what? 10 0 is 0. So when this is 0, it's 0. It's here. When 30 degree, it's 1 by root 3. So y value is 1 by root 3. 45 degree, it is 1. 60 degree became root 3. 90 degree became infinity. So look at this. What's happening is, you are here. When it became 30 degree, maybe pi by 6, it became 1 by root 3. Maybe somewhere here. Became 45, became 1. So it became, let's say, 1. 60 degree became root 3, more than 1. 90 degree became infinity, meaning it started going straight. So this is how you will see a 10 curve. It became flat, straight, and this is called what point? This is called a vertical asymptote. When for a given value of x, your y value goes towards infinity and becomes straight perpendicular to your x-axis. This is called a vertical asymptote, where your y value tends towards infinity post a certain value of x, or y approaching a certain value of x. When your angle was approaching 90 degree, it went towards this one. So, and again, I stopped at 90 degree. You will see that this same trend continues. If I plot 90 plus, basically, I go to the other side of the angle beyond 90 also. If I keep moving, you will see that these plots parallel lines, and after every time it hits a 90 degree iteration, right? So when you look at a unit circle, when it completes 90 degree, there is a problem. Hits the vertical asymptote. When it hits 180 degree, again it will hit the vertical asymptote. When it hits 270 degree, it will again hit the vertical asymptote. It hits 360 degree, again it will hit the vertical asymptote. So that way you will see that the same thing. Every angle that you keep on adding, every quadrant you keep moving to, you will see the same behavior keeps on repeating. So that's why, if you recall, the way we saw the sine curve, it was going like this. It was starting from 0 and repeating over every 2 pi, which was called the amplitude. If you look at the cos curve, it started from here and went pretty much the same way like a sine curve, just that it has a starting point as this is called period, this is called amplitude. So it started from the top of the amplitude and then repeated the way a sine curve goes. And then we also looked at how the curve moves along the x-axis, how the amplitude increases. Same thing applies here. Only thing is, with in the case of 10, with every 90 degree, you will see this pattern repeats. So that's the 10 curve. So this brings us to the end of what we wanted to do with respect to plotting of trigonometric functions. That's where we saw how do you derive or plot the sine curve, how do you plot the cos curve, and today we saw how do you plot the 10 curve. And for plotting these curves, we needed the right understanding of the table. That's why we looked at this table again, and we also went to make sure that you guys are not forced to memorize these values. We looked at how these angles or the value of the sine, cos and tan is derived for different angles in a more conceptual way, rather than being forced to take a picture of this in your mind and then doing it. Any questions so far? No questions?
No.
Okay. Alright. And we also looked at the unit circle, and then to find out how do you find the value of different angles. Now, I don't want to pick up a new topic today, okay? Because if I do so, we'll not have enough time to go through that, and we'll probably end up not doing justice with that topic. Now, if I, without having given you guys any information about things, right? If I just extend on the same topic and say, okay, find out the value of 10 minus 690 degrees. I'm asking you guys to find the value of 10 minus 690 degrees. Now what will you do? Don't try solving it. Tell me a story. Tell me an approach. How would you go about solving it? And if you guys don't answer proactively, I'll probably choose students of my choice. Randomly, I'll call out names to see who can tell me a story. Yes, Vishal.
Are we explaining it?
Yeah, I want you guys to explain it. I don't want the answer, I want the approach.
Okay. So first, I saw how many 90 degrees go into 690, and I got 7,
Mm-hmm.
and 7 times 690 is 630, and 690 minus 630 would be 60 degrees, and sine 60 degrees is equal to square root 3 by 2, and cos 60 degrees is equal to 1/2. So if you divide both of them, you get square root 3. And
Okay.
I got and since 10, I got negative square root 3, I think.
Okay. So one request to you guys. You guys know a lot of things, but when it comes to representing it, you guys start thinking that am I right? Am I not right? So don't doubt yourself, okay? Let it be wrong. When you say I think, right, that rings the bell for me that Vishal is not confident. Never ever say that word. In my mind, this is the answer. Don't keep any scope for any confusion or anything that deters your confidence level, okay? Let it be wrong. It will get fixed, okay? Alright, any other thoughts? Vishal approached it right, but I want to hear one more version. And I will open my mouth after I hear from you guys as well. Who wants to go for it? Chris, Neil, Dave, Ian, anybody? Woods. Anybody? Just one. Hello, who is this? Yep. Who wants to give it a shot? And you guys don't have to be afraid of me, right? I mean, I try always not to look scary. So if I'm looking scary, then you are mistaken. Give it a shot. Tell me a wrong story, that's fine. Nobody's judging anybody. Not a good sign. You guys need to be more brave. My friends, my kids have to be more brave. No reason to be shy. Okay, now, so Vishal, you pretty much nailed it. There was one thing that you probably overlooked. I said 10 minus 690 degrees. Minus. So, first thing you have to keep in mind is, how do we measure angle? If I am traveling in the anti-clockwise direction, then my angle is positive. When I count negative, when I go clockwise. When I am going clockwise, that is when it is negative. So if somebody says minus 690 degree or plus 690 degree, first thing I have to figure out is which way I am going and then where I am landing. And there's a difference. If you go, see, look at this. If you don't take that into account, there is a small possibility of big mistake. So if I am talking about 690, if I don't count, don't take positive or negative into account, what happens? 90 plus 90 plus 90, as you said, 7 times. So 3, 4, 5, 6, 7. 7 times 9, 630. And then other 60. I am coming to this point. Okay, this is 60. Now, if I am saying 690, same thing, I'll go. Say minus 690 when I am taking that negative into account, meaning I am going clockwise. 1, 2, 3, 4, 5, 6, 7. 7 9 is 630 and then 60. There's a difference. Okay. So how we measure the angle, which way we traverse, that makes a difference. Now I'm talking about 10 of 690, meaning since this one was right, this approach was right, this angle is right, 10 of this, meaning for this angle, let's find out sine and cos. And here, sine, this is falling in this quadrant. So I don't have to worry about the sine part, whether it's a positive or negative. This is the first quadrant. So for this one, if I find out the sine and cos value for this angle 60 degree, sine 60 degree is root 3 by 2, cos 60 degree is 1 by 2, sine by cos will give me tan 60 degree, and this is where I am stopping. So this is what is taking care of my this angle. So if I find out the sine and cos of this angle, divide that, I am done. But if I would have not considered the negative part, I would have landed here. My sine would have been negative, my cos would have been positive. This would have given me the same value but a negative. Yep. So this kind of questions you will come very often in the SAT exam, where you will have two options. Let's say somebody gives you this one, there will be one option with square root 3 and then one option with square root minus 3. If you don't think of the traversal part of it, there is a likelihood of picking up a wrong answer. Yeah. I hope this was making sense to all of you. So with that being said, I will probably give you guys 7 minutes back, and I'm still thinking whether we'll have the class tomorrow or not. Most likely I might request for skipping the class tomorrow, at least for you guys, because for all the kids in SAT group, we have a pre-calculus class happening on every Wednesday, 7 p.m. So you guys can join that class also. We can use the makeup class, or we can pick up a topic which is common between pre-calculus and SAT both. So that way, whatever we are losing today, that gets covered in that class. Will that be okay?
When?
That's it.
Wednesday, 7 p.m.
Okay.
That is only for as a makeup class for tomorrow's miss, okay? Because I got my uncle here who has traveled all the way from California. I'm just trying to use a day to spend with him. So if we can do that,